Okay. All right. Okay. Hey, Ellie. We are going to finish up the second half of 4.1, which is inverse functions. I think you should have the notes in the homework for this. There is that. So here we go. Do you guys remember on whatever day it was, Monday, what was the last time that we were here? When we talked about a one-to-one function. Yeah. Okay. So in order to be one-to-one, the original has to be a function, and the inverse has to be a function, okay? So if you have like this stuff going on like part A, and we want to tell whether it's a one-to-one function, you look and you say, is the original a function? So how do I tell whether the original is a function? The x's don't repeat on when it's ordered pairs. When it's the other like equations and stuff, you're right, Aubrey. Okay, but when it's ordered pairs, the x's don't repeat. So -2, -1, 0, 1, 2, the x's don't repeat. So this original guy is a function, yes. Yes. Okay, now I gotta look for the inverse. If I would flip them around, would the x's repeat? Or in other words, look at the y's. Will the y's repeat? Yeah. Yeah, these 2's right here and the 1's are gonna screw everything up. So the inverse is not a function, which means not one-to-one. Okay, that's part A. Okay, what about part B? One-to-one, not one-to-one.
Yes and yes.
Yes and yes. The original is a yes. The inverse is a yes. So yes, one-to-one. The x's don't repeat, the y's don't repeat, so he is a one-to-one function. Okay? All right. We're missing the table from the margins. I did not evidently get that copy pasted. So part C we have to skip because we don't have the data table for it. Okay. Now, how do you, we've talked about like what it means to be an inverse and like how you find the inverse and all that stuff, but we haven't actually like gone through and said like change this and make this an inverse function. We haven't done that yet. There are 4 steps to doing that. We did this in Algebra 2 and I think we did it in Trig last year. There are 4 steps to finding an inverse. So I'm going to do those 4 steps alongside while we do part A. Okay, so the first step, step number 1 is you switch f of x to y. You call it y instead. So if I'm looking at like part A will just be like y equals 2x plus 5. Like that's pretty easy. Step number 2, switch x and y. You switch them around. So step number 2 for part A will look like, nope, the 2 doesn't go with it. Just x equals 2y plus 5. Yep, you just literally switch the things around. Now, a lot of people do steps 1 and 2 at the same time, right? Like you can switch the y and then you can switch the x and y. So a lot of people do steps 1 and 2 at the same step. Okay, step number 3 is the hard step. This is like the meat and potatoes of it. This is the solve for y, right? So now that y is over here, now I have to get that y by itself. So step number 3 like requires the most work. Okay, so you're solving for y. That's step number 3. All right, in order to do this, Ken says -5. Okay, can you subtract 5 from x? It'll just be x minus 5. Yeah. Equals 2y. And then what? Divide by 2. Okay, how do you want to divide by 2? Do you want to divide the whole thing by 2? Do you want to divide each piece by 2? Divide by 2, the whole thing, okay? So just as long as you're aware that like you could either individually divide by 2 or you could divide the whole thing by 2. So now we have y equals x minus 5 over 2, that whole thing, right? Okay, that's done. Step number 4. You switch y and call it f inverse of x, and it looks like f to the -1 power. Do we remember this kind of? F to the -1 power a little bit, okay? Now, it's not actually f to the -1 power. Like there's a little note up here that says, caution, do not confuse the -1 and f to the -1 with the negative exponent, okay? Like f inverse is not the same thing as 1 over f of x, right? Like that's what the -1 power would do. That's not the same thing. They just ran out of things to call it, so they just put f to the -1 for the inverse, whatever. I don't know if that's why, but... Okay, so step number 4, I'm going to switch it around. I'm going to do f inverse of x equals x minus 5 over 2. Beautiful. That's what he looks like. Good? Good, good? Now, do you remember how, like, if they give me this function and they give me this function, how do I tell whether those two are inverses of each other?
If it passes the horizontal and vertical.
That's if it that would be if it's 1 to 1.
You can solve it and get the same.
Like, I can stick this guy in here for x, and it should come out to be x. I can stick this guy in here for x, and it should come out to be x, right? I'll just do one of those. So let's say I take the 2x plus 5. Don't write this down. Let's say I take the 2x plus 5 and I shove it in right here. 2x plus 5 minus 5 over 2. Like, I took this guy right here, and in place of this x, I put the 2x minus 5, or plus 5. You see what I just did? Now, plus 5 minus 5 goes away. What's 2x divided by 2? X, right? That's just checking the one direction, right? So that one direction checks out. I would have to check the other direction as well, and then it would work out. But yeah, so that's how that works. Got it? Now that I've made a mess of that. All right, B, step 1. Step 1 is done for you. Switch f of x to y. It's already called y. Okay, so now I'm going to go step 2. Switch the x and the y. So x equals y squared plus 2. Okay, step 3 is the hard part. Solve for y. What are you going to do first?
Minus the 2.
Minus a 2. Okay, minus 2, x minus 2 equals y squared. Then what? Take the square root. Take the square root. Okay, now I have y equals, and we put the square root in, right? So we need plus and minus in front of that, and this is what we've got. Step number 4, rename it, f in, and I'm going to flip it around, plus minus the square root of x minus 2. Got it? Good. These are inverses. Inverses. That was the inverse of a square function. What undoes x squared? The square root of x, right? What undoes a linear function? Another linear function, right? That's a linear function. Okay. What undoes a cube function? Cubic root. That's what we're going to do in part C. So, step number 1, switch f of x to y. Step number 2, switch x and y. If you want to skip steps and do those at the same time, you just go on for it. Step number 3, what should we do first? Yeah, we don't add the 2 over first because the 2 is underneath the cubic root, so we got to take the cubic root. Do we have to do plus and minus?
Yeah.
Only for square roots, 4th roots, 6th roots, only for even powered roots, okay? The cubic root doesn't have plus and minus. Y minus 2. Okay, then what? I gotta solve for y.
Minus 2.
Add 2.
Add 2.
Does the 2 go underneath of there or like
The outside.
beside it? Beside it, yeah, on the outside. So the cube root of x plus 2, right? Okay, and then step 4, f inverse of x equals the cube root. I'm switching these around. Good. So cubic root of x, that's what is the inverse of a cube. Not too bad, right? I don't mind it. Ugh. Okay. All right. Good? Happy with that? All right. Beautiful. Example 6. Oh, find this guy's inverse. Ooh, gross. Okay. All right. The following rational function is a one-to-one function. Find its inverse. All right. Step 1, switch f of x to y. I'm going to do it right there. Step 2, switch the x and the y. X equals 2y plus 3 over y minus 4. Now, this is the hard part because we have 2 y's. How are we going to solve for the y? Right. So, yeah, they put that in there because, like, they don't want, like, because there's a horizontal asymptote, or a vertical asymptote at 4.
Can you, like, multiply that over?
Yeah, I like that idea. Let's start there. Y minus 4.
And then you, like, combine them or something?
Y minus 4. Okay. I want to be able to get the y's together. So here's what I'm going to do. Normally I wouldn't, but here's what I'm going to do. I'm going to distribute this x through here and here. Just hear me out. Okay, if I distribute the x through there, what's that look like? xy minus 4x equals 2y plus 3. Got it. Like it a lot. Now, I want to get the y's together. I've got one y here and I've got one y here, and I want to put them together. Okay, so here's what we're going to do. I'm going to bump this y over here, and I'm going to bump this 4x over here because he doesn't have a y on him. Okay, so this xy is going to just chill. If I bump that 2y over, he will be minus 2y. Yeah? Equals what?
Plus 4x.
4x. Yep. Plus 3. Or you could do 3 plus 4x. It doesn't matter. Okay, now what do I do? How do I solve for y when there's two of them here? I'm going to pull a y out, which is kind of like dividing by y. I'm going to pull a y out front. What do you get if you pull a y out front? X minus 2. Ah, I don't know why I'm erasing. X minus 2 equals 4x plus 3. Okay, then how do we get this y by itself? Divide by that whole thing. X minus 2. X minus 2. So this is what y is equal to. You see how that method of our madness? Get the y's together on one side. So we're just going to multiply that over. Multiply that like through, and then get the y's on one side and the x's on the other side, and then pull the y's out. Okay, so final answer, f inverse of x is 4x plus 3 over x minus 2. Similar numbers is what we had up here, right? Okay, we had a 2, a 3, and a 4, what? Yeah. No, it wouldn't work that way because, like, you're dividing, like, this guy's trapped together and this guy's trapped together. So, I mean, you could do, like, division if you wanted to, which would look kind of weird. I don't know. I would just leave him like that because he's in kind of the same format as what he was to begin with. Okay. All right. In each set of axes, the graph of a one-to-one function is shown. Graph the inverse. It's already done for us. That's kind of boring. Okay, so right here they have this line. Let's say they give us this line right here. And this is the dot 1, 3, and this is the dot 0, negative 4. Okay, if I'm trying to invert those, how do I invert coordinate points? Like this guy and this guy. Flip it. So 1, 3 becomes 3, 1. I've got this dot here. 0, 4 becomes negative 4, 0. And now I have this guy. And one thing that visually you should see is that, do you see this dotted line? What's the name of that dotted line, by the way? Y equals x, right? Y equals x, that's a linear function. He should be reflected across that line. Inverses are always reflected across that line, okay?
It shows you this. How do you tell which one is like? I guess
Yeah, it doesn't. It doesn't matter. This could be the original, and his inverse is this guy, or this could be the original, and that guy's the other guy. Evidently, the red one was the. Oh no.
Wait, so we're wrong because
The graph of the one-to-one function f of x is shown in
it says
blue.
x1 is 1, 3, 0, negative 4.
Oh yeah, so this was the original one. This is the blue one. And then the red one is this guy. So this is his inverse. Whoop. This is the inverse one. Yeah. So here, the original guy, the blue guy, was this guy, right? But he has coordinate points 2, 4, and 1, 1, right? Now, the red guy, if we take 1, 1 and we flip it, it is also 1, 1. If we take 2, 4 and flip it, it's 4, 2. And so now he looks like this. Are they flipped across this dotted line? You betcha. So there is that. Okay, good. Last thing, they want us to find the inverse of this guy. Okay, and we'll talk about this here in just a second. They want us to find the inverse of that function. So 4 steps. Anytime they say find an inverse, go through the 4 steps. Step number 1, y equals that. Step number 2, x equals square root y plus 5. Okay, we're just going to find the inverse like normal. All right, now we're trying to solve for y. Y is right here. What? We're going to square it to get rid of that. Yep. Okay, so now we've got x squared equals y plus 5. And then what? And then what?
Minus the 5.
Minus the 5. Minus the 5, so y is equal to x squared minus 5. Okay, and then I'm going to rename him. So f inverse of x equals x squared minus 5. Okay. All right, real quick. Do you know what the square root of x plus 5 looks like? Like the square root is, no, the square root is one of these. Whoop. But what's a plus 5 do underneath of the thingy thing? Moves him to the up 5 would be like this. It moves him left 5. 1, 2, 3, 4, 5, and he looks like this. Now, the reason why they say this is that x has to be greater than or equal to negative 5, right? Does he go to the left at all of negative 5? No, that's why they put that there, right? Because we can't plug in numbers to the left of negative 5 because they don't exist, right? Do you know what this guy looks like? X squared minus 5.
Upside.
He is a parabola, right? He's a parabola, down 5. 1, 2, 3, 4, 5. And he's a parabola, and he looks like this, right? Okay, except here's the deal. This, look at my black one, right?
Hey, I was right.
Yeah, my black one, look at this black one. He only has one little piece of him. He doesn't go this direction also, right? But my x squared function like goes both little loop-de-doos, right? But I only want that loop-de-doo. How do I say that I only want this loop-de-doo? Like here they said x has to be greater than or equal to negative 5. What does x has to be greater than here? The x coordinates have to be greater than or equal to what? That's why. If we're talking about this little loop-de-doo. What?
Is it, wait, what?
If we're talking about just wanting that little loop-de-doo. What?
Plus 5?
Mm.
I'm so confused.
This little guy right here. That's what we have here, right? And they're saying x has to be greater. So here's where negative 5 is on the x-axis, right? They're saying x has to be greater than negative 5 in order to be that guy.
So it needs to be greater than where it hits the y-axis,
Where does it hit the y-axis?
x-axis.
Where does it?
0, negative 5.
What's the x coordinate right here? This is at 0, negative 5.
I said that.
What?
I said that
So x has to be greater than or equal to?
like a long time ago.
When? What? What did you say?
That's why I'm so confused.
X has to be greater than or equal to what?
Negative 5.
No.
What? 5. 0.
No. 0.
Oh, just kidding. I did not say
Just kidding. You did not say that. I know you said negative 5, but 0, negative 5 is here. The x coordinate is 0, right? So x equals 0 is right here. We're only talking about guys to the right of 0. Got it? So this little guy keeps, whoa, what just happened? I know. This little guy keeps me from doing both of the little loop-de-doos on my parabola, right? It only gives me the one loop-de-doo. Does that make sense? Yeah. Kind of weird. Now, he is reflected across that dotted line, though, right? Yeah. So, because the inverse is a parabola, we have to do the x is greater than or equal to 0 to only have the one little loop-de-doo. Okay, all right. You guys have homework? I think some of this homework is maybe matching. I don't know. A lot of it's probably going to be the do the 4 steps, find the inverse thing,
A
go.
lot of it is plugging into the g of x at the
Oh, yeah, okay. All right.
I remember
I'm excited because next we get to start doing exponential and log functions. I like it. I like it. You don't like logarithms? You'll like logarithms.
I do.
You do?
Trig.
Yeah. It's gonna be all right. It's gonna be all right. Yeah. Oh, it'll come back to you real fast. There's rules and like, it's all algebra stuff.
I watched you guys do that stuff in Trig and I'm just like solving it in my head.
Yeah. Nice. Yeah. Perfect. Okay. All right. Bye, Ellie.